Hi.
Hello, Julie. How are you?
Hi, I'm good, thank you.
Well, I'd like to introduce the two of us to our audience here.
Yeah.
So I'm Una Parsons. I'm the head of college at ATU Sligo, that's the Atlantic Technological University, and I'm also the head of faculty of engineering and design. And you, Julie, are?
I am Julie Coleman and I am a Phase 4 apprentice up here doing toolmaking at the moment.
And Julie, that is why I want you to share your story, because it is so unusual. Well, first of all, the trade of toolmaking, not a lot of people know what it is. But secondly, to have a female doing it. And just, what's really unique about this is that I also did toolmaking way back when. So it might be interesting for us to chat about that, the differences we found between...
or how we fell into it, I suppose.
How we fell into it.
The best way of saying it.
Definitely. So tell us about your journey, Julie.
So I honestly didn't have any idea what toolmaking was before I started. My father is a toolmaker down in Cork, and when I was looking for something to do after I left college, I wanted something that could be hands-on and something that would broaden the horizons of what I wanted to do with my career. And I literally fell into toolmaking. And when I started working down in ATS, I realised that it actually touches everything that we use every single day. Toolmaking is such a vital part of the industry of what we use in work, at home, and I loved that. I thought it was so interesting, and it's a really small apprenticeship, which I think is ridiculous because it's so important. But at the moment, like learning about moulding and turning and everything that we're doing down here is so interesting, and I still have a long way to go, but I've realised as well with toolmaking that there's a lot of paths you can go down afterwards, which I think a lot of people don't know about, and it's really important.
Well, let's maybe explain toolmaking first. Okay. And I think a lot of the audience, like you and I, when we started initially, had no idea what toolmaking is.
No.
And the whole public have no idea that nearly everything we touch and feel, the tools that were used to make that product. So what I have with me here is one of these new keep cups that we have in ATU Sligo.
Yes, we're going green.
And between us, we're going to explain what a toolmaker might do in order to make this cup. So if you turn the cup upside down, you can see a little point in it.
Yes.
And that would be where the plastic is injected in to
into
a tool, into the mould. So maybe can you talk a little bit about what you think happens then?
Well, what I know happens, from learning here, is that as a toolmaker, we design the mould itself. So we make two parts that would kind of go together, and as you said, we'd inject the liquid plastic in and wait for it to harden and cool. So if you can see, all of this here would be kind of pushed into the mould, and then there'd be different cycles and phases that it would go through. So it would also be blown out as well in a second mould, if you want to explain that a little bit better.
So the moulds are quite complicated. There's a lot of detail with them.
Yes.
What's very important with them is the tolerances and the precision that's made in order for the metal parts to come together. Because if they're not precisely coming together, the plastic, when it's put in at that high pressure, can squash in every direction. And then you get loads of lines that you don't want to, you want a smooth finish.
Absolutely.
You know?
Absolutely.
And then even the finish on this cup has got all these ribs. So that's quite a complicated mould. To machine out the tooling to create that would be quite complicated.
Yes, it would, definitely.
And then because it's tapered, the way the mould would come in and out, again, would be complicated. So there'd be a lot of slides and so on and so forth.
Yes, that fit and that wear as well over time. That taper can change and things like that. That's where a lot of toolmaking has gone towards today, is maintenance of moulds, keeping them accurate, keeping them precise.
And nowadays, in order to cool the mould, right, so the mould is at a very high temperature because the plastic is at such a high temperature, so it can get hot. Yes. So you have to keep the metal cool. So there's lots of cooling channels in the mould, and the technology that's used nowadays to keep the mould cool, conformal cooling is one of the new terms of the way it's done, right near the surface. So that's quite complicated, and to get that right. And I know, in the pharmaceutical industries, in medical device industries, an awful lot of plastic parts.
Yeah, exactly. Especially in pharma companies, you'll find a lot of things that you would use are done through injection molding, and when it's explained kind of like that, it sounds like a very simple way of doing something. But as you've said, like the tolerances and how precise and exact it has to be is critical. Like there's a company in Ireland that makes the inhalers for asthma, and those tolerances are extremely tight. They're, I think, almost at 0.02. They're really, really tight. And I think over time, what I've found with tool making is the more that technology and the more that the industry develops, the more critical it is that the molds are accurate. So it's very, very important. It's better to call tool making precision engineering at this point, because the plastic is the least important part that goes into the mold. The mold itself is what is important. So I think that the cup is a very good way of explaining it, but that it's probably one of the more basic things that tool makers are developing nowadays.
And I know we said molds are one aspect of tool making. I know the industry you work in, you make a lot of jigs and fixtures, right? So for example, I started my career in Braun, which made the hair dryers and the curling tongues, lots of plastic parts.
All very essential things.
And one of the first jobs I had to do was to create the grippers that would take the curling, the hair dryer out of the mold. So for instance, in this cup here, how would you lift it? Once it cooled down a little bit in the mold, how would you lift it out and put it on the conveyor belt? So to get the gripper that would move, and it was kind of like a robot arm. So to create those parts is what the toolmaker was doing as well.
So important as well, not to leave a mark either when you're taking it out, anything like that. There's so much that goes into something that seems so simple, and it's what you did back in
1978. 1978. I did my leaving cert in 77, and I started in. Well, I actually started in 77 and came to Sligo. Did my block release here in 1978. And I suppose one of the reasons I got into it is I liked sewing. And sewing is something very precise, working with your hands. And when I read the description, because none of my family were into tool making, when I read the description of tool making, it sounded really interesting to me that it was such high tolerances, precision. I liked that. And it was quite unusual for the likes of us to go on a journey doing that. So tell us what it's been like. You know, you're a female in a male-dominated environment. How have you found that?
I actually think the way you just explained it there is very good, that how precise it is, how critical it is. You think that it would kind of resonate with women a little bit more. That kind of accuracy and that precision is there in us to want to do that. So I was actually a little bit surprised when I started that there wasn't other women. Now, I didn't think that we'd outweigh the men, but I didn't think I would be the only one. Now, working in a male-dominated industry has its challenges, but I think that times are changing and that men are starting to realise that although over time they used to have all of the cards, we're starting to learn the rules of the game as well. And it's much... I'm trying to explain it and keep it proper, but it's so important for women to be a part of this industry. We understand what's going on and we want to be involved, and we can make a huge difference. I mean, how far toolmaking has come in the last 40 years has been a lot. But how far it's come in the last 10 years? Because there's more females out there. Maybe that's me being a small bit biased, but I think that it's so important for us to get involved, because the game is changing and it's still moving. And if we don't get on board and get involved, they're going to take off without us. And I think that toolmaking is a fantastic apprenticeship to do, specifically for women. I think it's catered to us. I think it's not dirty work and it's not too hard. It's given me the ability to use the resources that I already had and become much more confident in what I'm able to do and what I'm capable of. And yes, maybe the door was held open for me by a man, but knowing that you're there, knowing that there's women in the industry who want us to do really well, it's changed how I look at toolmaking completely, especially since coming here and meeting you.
And I know when I started my career in toolmaking, there was a lot of manual work.
Yes.
So I can remember many's the hour filing by hand and bringing up the polished surface and so on and so forth in the metal, because you needed the polished surface in order to get the plastic flowing, and it wasn't lumpy, and it was a lovely finish. You can nearly see your face in the plastic that came out. But since then, technology has changed completely, and CNC, computer numerical controlled machines, have transformed the way tool making is conducted. In our tool room in Sligo, it is state of the art. We've put millions into the equipment that we've bought there. It looks fantastic. And I know in the industry you're working in, there's a lot of computer-controlled equipment. Maybe just describe what that machinery does.
So I work exclusively with CNC. So there's kind of a half and a half. There's the conversational CNC, which is standing at the machine, programming it there on the computer. And then there's going to another computer and using programs that, like Mastercam and SolidWorks, to design those parts, program them and bring them in. And I think it's really important that it's gone that way, because as you said, how precise and how exact that we have to be in the industry, that computerized way of programming has made it easier for us to find those little things that might be going wrong and just change them ever so slightly, instead of, as well, it removes that human error, kind of that area of it. And like, as you said, in the tool room up here, you can see that natural blend from manual down to the CNC, and the further back you move in the tool room, the more accurate you become. So that CNC work that I do, especially with pharmaceutical industries, is very, very critical. And yeah, it is a little bit less manual work, but that's kind of where I've found that tool making has really come into its own, that ability to design something on a computer and then bring it to life. That's where I find that tool making is the most important, and it's made such a difference.
And could you describe to me, you said some of the work you're doing is for the pharmaceutical industry, and you're contractors for the pharmaceutical industry. So what kind of tools would they be asking you to make? Just give us an example.
So we make a lot of dies for some of the bigger pharmaceutical companies.
So what's a die? What's a die?
So a die, well, dies and fixtures, kind of, we call them dies, but they're not dies. I can't explain it correctly. That's what they call them. They're not, I wouldn't call them dies as they are in the textbook, but what they want us to make for them is something that they can put into a fixture and that it will repeat over and over and over again, that no matter who is on it, no matter what operator is working it, it'll produce the same product over and over again. So we make a lot of small dies and fixtures for companies. So a lot of boards we'd make for them to, like, that would push in blades, and they'd cut blades, and they're used in surgeries all around the world, those small little finicky tools that are used. So we push in blades, we cut them, push in blades, cut them. It's a very repetitive motion, but that's the idea of the tool making, is we can make something that can be used on a production line, and that's kind of the main thing that my company does. But yeah, there's a lot of different ones you can use.
So that example there is that your company is making a tool that's cutting metal.
Yes.
Yes. And what we described earlier was something that was injecting plastic.
Yeah.
So it's two separate things.
Completely.
So typically in the dies, you're shaping or cutting metal.
Yes.
In that regard, so it just shows the variety. So car manufacturers nowadays, a lot of the metal parts are cut out, right, and then they're shaped. That cutting out, that tool that designs that, that's a tool maker that designs that.
Absolutely,
and you're doing it on the minute scale for the pharma industry, for metal parts that are used by the surgeon to cut us open on the table. A tool maker is making those scalpels, the tools to make the scalpels and that sort of thing.
And most of them, for them to have longevity, would be kind of, they'd be hardened over time, and we'd make kind of backups of them so that if something did happen on that production line, the point of what we do is to make sure that if production has to stop, it doesn't have to stop completely. There's a quick turnaround, a quick fix that we can provide for them so that they stay being as efficient as they possibly can. And I think that's something that, as you said, I do on a minute scale. So for someone at home who's like, oh, I wonder what a die is, I wonder what a fixture is, and they look it up and it's this big thing. Tool making is involved in every single industry, and I think that's a really good example of it, is that I do it for something that is so small, And then there's another company out there, as you said, who's making it for car parts, or they might be making fridge doors. There's a million and one things, and you need a toolmaker for all of them.
Now, you mentioned a word there called hardening, right? So maybe everybody's not aware why you need to harden metal. And one of the main reasons is that the metal will wear.
Yes.
And, you know, you can imagine if you got a tool that had to repeat all these scalpels for the surgeon, you don't want it wearing every few runs. So what you do is you harden the metal so that it'll last a lot longer.
Yes.
Maybe you could describe the hardening process.
Okay.
What happens there?
So first of all, hardening doesn't work on every metal. There's certain ones. So steel, yes. Aluminium, no. Things like that. And basically the process of hardening is when something is made, if we have to bring it to a certain dimension, we'll leave a small bit on. We'll send it away to be hardened. Some companies, some of the bigger companies will have a hardening within their shop, and it's put into, for all intents and purposes, an oven, and it's hardened to a certain, what we call Rockwell. So different steels have a different Rockwell that would bring it to the same hardness, and then it would come back to us. And in the hardening process, because you're putting such an intense heat into it and then you're letting it cool down naturally, when it comes back to us, it can bow and it can pull, which is why it's so important to leave material on. And then we bring it to the next process, which we call grinding, and we take that down. And so when we say hardening and it's hardened, it's still not finished. There's still so many more processes after that before we can send it out to the customer or before it can be used. But there's a couple of different hardening methods. Some of them, you know, you harden, you let them cool naturally. Some you harden up to a certain heat and then you bring them to a very cold temperature straight away. So there's tempering and hardening. But what I do is in my company is I use hardening, and I find it gives a great longevity to all the tools that we use. Now, it does not make them perfect, but it definitely helps, and it's great.
It's like baking a cake, and there's all different recipes depending on what the outcome or what you're looking for.
Absolutely.
And if you don't harden and temper correctly, the metal can crack.
Yeah.
So it's very important to follow the recipe, to understand what's happening, and that's why there's specialist hardening companies. A lot of the contractor shops would send their work out to them because they're doing it all the time.
Yes, and it doesn't make them, last forever. Like if you have a piece of hardened steel and you drop it on the floor, there is a chance it will crack. But the point of hardening is that the outside of it becomes a lot tougher and stronger, so that, as you said, over time, if it's used in a production line, it doesn't wear and it doesn't mark. It stays clean, and that's a huge part of the farm industry, is this clean environment and this clean area, so that everything that they do is up to a certain standard. That's why hardening has become very important as well. It doesn't mark and it doesn't get dirty, and it just works very well with the industry that it's going into.
Definitely. And before you even bring it to hardening, you mentioned that you would cut the metal. So there's two main tools or machines that are used to cut the metal, the milling machine and the turning machine.
Yes.
Maybe you could explain the difference between those and what they do.
Okay, well, the mill basically, I would call it has an X, a Y and a Z. So the head is vertical, that comes down, and we put our tools into it, and the steel itself is on a table. That is our X and our Y. And our turning is then, that would be for kind of diameter pieces, and that goes into a chuck, and that only has, it only has a Z and an X, shall we say. So the long pieces go into a lathe, which is the turning machine, and we'll turn down diameter pieces, and then the mill itself would be for vertical milling, or there's also horizontal milling as well, but that's for all square blocks and things like that. So they have two different purposes. If I wanted to make a pin, I'd put it on the lathe, and if I wanted to make a block, I'd put it on the mill.
Okay, so one is for turned more cylindrical pieces, and one is for more square rectangular pieces.
Yes.
Excellent in that regard. Any suggestions for anyone in school that's interested in doing going to college versus doing an apprenticeship? Now you are interesting in that you started in college first, and now you're doing an apprenticeship. So any tips you'd give anyone out there?
I think there's a lot of work that needs to be put into the apprenticeship to make it seem more accessible, specifically for women, because That's what I know. I think that an apprenticeship is the ideal way to learn. You get the experience of actually working, earning money, and then you get the experience of going to college, sitting down with people who are actually experts in what they're teaching you about. When you go to college and there's a lecturer up at the top of the room, they might have studied for years and gone straight into teaching. Whereas more than likely, when you do an apprenticeship and then you go onto your phases, so phase 2, 4 and 6 would be what we call off the job phases, more than likely you're being taught by a toolmaker. That makes such an impact on your ability to go back to your workplace and what you can do and what you can give them. I think that an apprenticeship, it's not what it was before. Like even when I speak to you or I speak to my dad or other people I know who've done apprenticeships, it's very different now. It is not the easy route. I think that's something that's really, really important for people to understand. A lot of people think, oh, I'm not might be that good in school, so I'm going to do an apprenticeship. There's so much more work involved in an apprenticeship because you have to show up every single day. There is no off day. There is no time off. You go to work and then you learn. And that makes you much more capable because in work, you learn commitment and you learn about showing up. And then in college, you learn what you need to know to become very talented at whatever apprenticeship you choose to do. And I also think as well, for women specifically who aren't so sure what they'd want to do, the apprenticeship isn't carpentry and electrician. There is so many to choose from, just like in college. There is something out there for you. You just have to look. You will find something that you can be very, very talented in, and people will pay you. People want you to do this. What can be more affirming than being told you're good at something and waking up every single week and getting money into your bank account? I think it's
so you would
vital.
Certainly highly recommend it. And
Absolutely.
I know we often have industry and employers coming to us wanting to know, do we know of any qualified apprentices that we would recommend, because they're crying out for people to work in the industry, particularly in the precision engineering and toolmaking industry.
Yeah, it's such a small apprenticeship for how big an industry it is, and I think that the responsibility is on past apprentices to let people know, because it's a lot easier for men, you know, to see their older brother or their cousin or their uncle or their dad who's done it, that, oh, I'll follow them and they'll show me what to do. And then you look and you think, oh God, no, she won't be able for that. Yeah, you will. And you'll probably be better than half the lads in your room. Like, the ability to be an apprentice is out there. Everybody has it. You can do it. Like, nobody's questioning that. It is a little bit daunting, but if you don't know what you want to do, you'd go to work. So why would you not go out and work and come out at the end of it with qualification, with career? That's what an apprenticeship is. It's not a job. It's not unskilled work. It's a career. It's a life. And to be able to do that, I think, is the best thing ever.
And it'll always stand to you. A career in an apprenticeship.
Yes.
I myself did my apprenticeship. Then I did the opposite to you. I went to college afterwards. But by having the background of the apprenticeship, you really understood how to make things. Yeah. So I wasn't designing machines that I didn't know how they would be made. So it's a great backbone to have, no matter what you go into. If you stay in the trade or you move into something else, it's a great backbone and thing to have.
Absolutely. When you can realise that, it becomes much easier to understand.
Well, we are two advocates for the trade. I'd like to share with everyone that Julie's dad and I started our apprenticeship together, and I only met her last week to learn who she was. Yeah. And it's so unusual to find somebody doing the trade of apprenticeship in toolmaking who's a female. So that's why I was delighted to meet her and share the story. But I think the whole world of apprenticeship in toolmaking is unknown to so many people. Yes. And that's what we wanted to say today. So many of the big companies, the multinational companies that came to Ireland, rely on toolmakers. Yeah. When I started toolmaking, all the toolmakers in the multinational companies were brought in from England. We had none in Ireland. So we have developed the trade of toolmaking particularly here in Sligo. We have the National Centre for Training for Toolmaking. And over the years, the numbers of toolmaking in Ireland have dropped off. And what we're finding now with industry, they're having to import and bring people in from other countries again. So we want to get the word out there that there's a great career in toolmaking, encourage anyone to find out more about it. Yep. Check out our website, come in and have a look at our fabulous tool room here in the college, and ask around in your local industries where there are toolmakers work and learn more about it.
Absolutely. We need more women. You paved the way for me, so hopefully I can do the same for someone else.
Great. Julie, thanks for being my guest.
Thank you very much.